Hi guys, how's it going? This is Carl, and this is week 10, problem number 4, and we'll go ahead and just kind of get started. Marketers ask the question, did you use the internet yesterday? And, and what is your educational level? In this response to the question, the internet of the educational level completes parts A and E. So what you see is kind of survey data, education level right over here, and by whether or not they did or used the internet yesterday. So it's kind of a cross-cut, simple 2 by 2, or not 2 by 2, but simple frequency table. We went ahead and did total calculations. This 4820 is the grand total of responses, as you can see. And so in this total column here is the number of individuals by education level, and these totals represent the number of yeses and nos in terms of this question. Did they use the internet yesterday? So first part is under the null hypothesis, what are the expected values and what are the hypotheses? So for our null hypothesis, the educational level and internet use are independent. What does that mean? That they are not related. And another way to say that is that a person's educational level is not indicative of their internet usage. So that's the null. Alternative means that they're not independent, which means they're related, which means that there's a relationship. So in essence, for instance, college education is an indicator of internet usage. So that's kind of what we're getting at here. And you can see here what we're doing with the expected values, because that's the other part of our question, is just like we've done before, we're taking the total of the row. So for instance, this is less than high school. We answered yes. What's the expected value? The total of the row, which is D2 right here, divided by the total of the responses for yes, which is right here, divided by the grand total, which is D6. So D2 divided by, or times B6 divided by D6. And as you can see it, just kind of going across, you'll see the pattern, D3. So in terms of high school, it's the total number of high schoolers times the total number of yeses, because we're dealing with yeses here, divided by the grand total, which is D6. So you kind of see that all throughout, and the same thing with no. You'll see here just arbitrarily for the number of high schoolers with no, the expected value, well, it's the total number of high schoolers right here, D3, times the total number of no's right here, 1278, then divided by the 4820. So that's how we get our expected values by answer by education level. Now if you go a little bit further down, computing this chi-square statistic. So with our chi-square statistic, it's the same kind of scenario. We're doing the observed minus the expected squared divided by the expected. So what does that mean? Well, an observed is already up here, as you can see. This is our observed, these values based on the survey. Our expected is what we had just calculated, what we just went over, and it's the same pattern, the same method. We're doing it by answer by education level. So the observed value of less than high schoolers that answered yes, minus the expected value, which is B13. You see it right here. Square it, then divide by B13. And you can see that's the pattern here. You see B3, which is the survey data result, minus the B14, which is right here, squared, divided by the B14. So you can kind of see how this is working in terms of calculating the chi-square statistic by answer by education level. And if we sum them all up, we get 191.1232. Our next question is, how many degrees of freedom does this have? And for a chi-square test of independence, there are r minus 1 times c minus 1 degrees of freedom. What does that mean? Where r is the number of rows, and as you think, c is the number of columns. So what do we have up here? Just kind of showing you. We have 1, 2, 3, 4 rows. We don't include this because these are just calculations. So 4 rows and 2 columns of data. So that's how you see it right here. 4 minus 1 and 2 minus 1, we get 3. That's how many degrees of freedom. Our next question is, find the critical value for alpha equals 0.01. What does that mean? A 90%, actually 99% confidence level. That's what we're looking at. And how do we find the critical value with that 99%? Well, as you can see, we put our chi-inverse function 0.01 and 3. What is 3? Well, as you can see here, 3 is the degrees of freedom, and p is the probability. So that's what alpha is in this kind of calculation. It's the probability and our degrees of freedom. And that is our critical value. So what's the conclusion that we could draw from this? Well, a piece of it, and what really kind of helps us, is these degrees of freedom, this chi-square, our chi-square up here, our total, and the critical value here. So to reach a conclusion about the null, compare the chi-square statistic to the critical value. If the statistic is greater than the critical value, reject the null. What does that mean? Well, we go back up. So this is our chi-square statistic right here, 191. Our critical value is 11, so that's for sure greater than our critical value. So we reject the null. What does that mean? That means that educational level and internet use are not independent. Oops. So what that means is that there is a relationship. There is a causal relationship, or you can infer that there is a relationship between internet use and education level. That if one has a higher education level, one is more likely to use the internet. And so that's kind of what we're able to prove based on this survey data. Now you can also kind of factor in, if you're actually writing a report and kind of discussing this a little further, different kinds of socioeconomic, geographic factors that could kind of let you, if anything, kind of act as a limitation in terms of interpreting this and generalizing this output. So, but we just hope this helps, and just let us know if you have any questions along the way. Thanks so much. Bye.